Hello, and thank you for attending this session of the Ansys Innovation Conference for 2021. My name is Jim Delap, Director of Product Management at Ansys, and today I'll be discussing the promise of 5G and the challenges faced along the way to implementation. So for several years now, we've been hearing about how 5G will be everywhere. It will connect us to our mobile phones. It will connect us through our autonomous vehicles. It will connect remote sensing to infrastructure, and it will connect remote surgeons to patients located miles, thousands of miles away. We're hearing that 5G is the future of telecommunications from the device perspective, empowering mobile devices of all kinds to generate data and also consume data from our mobile devices like our smartphones. It will impact our networks. More and more data will be transported wirelessly across 5G networks, and we'll need to connect to the very broadband nature of the internet backbone. 5G is also promised to be the connection mechanism for large-scale data centers, and basically need to connect to compute clusters and cloud infrastructure. So this is promised to be a ubiquitous piece of our life, impacting us in many different ways, from our homes to our mobile smartphones, to our vehicles, and even to our healthcare. So this is promised to be a big part of our lives in the future. Hasn't quite gotten there yet, and we'll discuss that as we go along. And 5G has been all about the promise of a flood of data for all sorts of different applications. With higher network speeds and higher access, more devices connected via 5G, we have this opportunity to be able to consume and deliver much more data between devices. Things like autonomous vehicles will be having sensors in every aspect of the vehicle, and will be able to communicate not only with the factory to tell when the automobile needs service, but also with nearby vehicles to make sure that speeds are maintained and everyone can travel safely autonomously on the road. We're also here about machinery and platforms like aircraft that will generate a lot of data to make sure that these devices operate safely and can operate over a long period of time. So we're talking about terabytes of data that is generated every day, transmitted across these 5G networks. And there was a quote from Cisco a few years back that predicts that by 2021, a 5G connection will generate 4.7 times more traffic than the average 4G connection. But I'm not sure we've really met that milestone. 5G has had a lot of promise, but it hasn't really come to fruition quite yet. There have been a lot of challenges along the way, and the promise is a lot harder than we anticipated. In the US and across the globe, there are slowdowns in rolling out 5G network infrastructure across the country. We're seeing different types of reasons, whether it's from limited spectrum or network infrastructure not ready yet, or really there's no consumption of all of this network data as of yet. We don't have as many autonomous vehicles on the road as we expected. There are only so many movies that you can stream from your car these days. Additionally, we've also had challenges with some of our customers in this space over the past year. Everybody has had challenges redirecting and reshaping the way they do business with the impact of the coronavirus across the globe. And lastly, that has also impacted things like semiconductor shortages. So over the past year, the pandemic has affected every aspect of our lives and is now infecting and affecting aspects of technology like rollout of 5G infrastructure. So at Ansys, we are trying to do our part to help ease that burden and help our customers realize their promise of delivering these 5G systems in a more efficient and cost-effective manner. If you look at electronics and how Ansys Electronics is impacting these systems, we have analysis and simulation technology to help the design of high data rate systems, such as network infrastructure, routers, network fabrics, things of that nature. We also have the ability to affect end user equipment, smartphones, user equipment at the home, satellite, or not satellite, 5G antennas on vehicles, as well as affecting the design of edge processing equipment. That's basically computing equipment at the edge of the network, and also the infrastructure and large communication environments. And Ansys is the market leader across all of these segments, starting from our foundation in mechanical, fluids, and electromagnetics, the core physics that are at the heart of Ansys. We've also added the capability in optical systems and semiconductor devices, building on top of that with systems and embedded software analysis capabilities. We also have world-class material system and our cloud and platform that supports all of these products across a variety of industries, including 5G. So let's take a quick look at how Ansys Simulation is affecting one area of the 5G system by looking at the infrastructure and high bitrate systems. We can look at a basic scenario of a cell site router for LTE and 5G networks. Most of these components are some kind of fiber optic routed systems. So you may have racks of these types of routers. Each of them have some kind of network ASIC or network fabric switch, along with electro-optic transceivers to take the fiber optic signal and transport it across the PCB, and then transmit and receive that across the entire core of the network. So this is a typical build out in one of these gateways, and we can look at this in the Ansys ecosystem from a variety of perspectives. Looking at the electrical side of things, we know that we have to interface with the optical devices and the fiber optic patch cables that go between these routers. And last year, Ansys acquired Lumerical, which provides a suite of full photonic multiphysics design tools for components such as lasers, optical photodetectors, displays, and also circuits and systems. So we can take these components and combine them with the electrical analysis from the traditional Ansys electromagnetic suite. And with that, we can also look at things like signal integrity and power integrity across the printed circuit boards that are part of these cell site gateways. So one example of this is the ability to use Ansys HFSS to analyze very high speed channels across this printed circuit board that would perhaps go from the optoelectric connector to the board to some kind of fabric switch that is mounted on the board. So here what we can do is an electromagnetic extraction of the signal as it passes through this board and get a very accurate description of the channel S parameters, and combine that with the electro-optics from Ansys Lumerical into the interconnect system to be able to get a better idea of the entire transport characteristics. From the PCB itself, we also have the ability to use HFSS to combine electrical and mechanical CAD. We have the ability to take in the electrical CAD layout, combine that with the mechanical CAD of things like the connector that you see here, as well as the memory DIMM that is mounted inside of that. And from this complete analysis, we can look at the electromagnetic characteristics and potentially uncover where there might be coupling that should not be there. So on the bottom left, you see an animation of a section of a printed circuit board with a memory DIMM connector along with that DIMM module. And analyzing all of this together allows us to accurately capture the electromagnetics of this design and more accurately predict any problems we might have with signal integrity. So continuing on that thread, if we look at the overall system analysis here, what we're doing is we're taking the extraction of the printed circuit board, we're combining that, as I mentioned, with the electro-optic modules and even a model of the fiber channel itself, and looking at the end-to-end performance to predict and design and make sure that we are able to accurately model this entire system and make sure that it meets the design challenges for these 5G interconnects. Now, if we dig in a little bit deeper and look at devices that are actually mounted on the printed circuit board, HFSS has grown drastically in capacity over the last few years in terms of being able to solve larger and larger systems. And we've been able to take as much as an entire die, a transceiver die, as you see over on the right side of the screen, we've been able to take that inside HFSS and model the entire electromagnetic characteristic of that 30mm square die. So with this capability, we can combine more and more of the electromagnetic systems into one signal analysis. Here's a little bit deeper look at how we are doing that in accessing this from our new product, Raptor H. And Raptor H is a basic way to get the information from the IC design flow into the engine of HFSS. And this is how we are able to completely analyze this entire RFIC chip inside of HFSS. Now, if we extend this beyond just the electrical domain, we also know that all of these chips, everything working together, is going to produce a lot of heat. So within Ansys Electronics product ecosystem, we also have thermal analysis capabilities so that we can link electrical characteristics such as current conduction on a printed circuit board and current conduction through connectors, all with the device, the chip models from the thermal aspects. We can combine all of this in Ansys IcePack to get a better understanding of the signal, power integrity, and even thermal integrity of the entire network infrastructure. So this is a very nice way of being able to combine everything into the system analysis, so we can look at this from more than just an electrical perspective. And going beyond that, once we have a good design, we also want to make sure that this product is going to last. So we can take this and take all of the electrical and thermal data and pass that over to Ansys Sherlock for a better prediction of electronics reliability. So that was a quick look at how Ansys Electronics portfolio is helping with the design of the 5G network infrastructure equipment. Let's turn our attention a little bit smaller scale to look at 5G user equipment, things like smartphones or IoT devices. With the higher speeds and the millimeter wave frequencies of 5G, we have a lot more complicated antennas and antenna systems that need to be designed. And they also have stricter standards that need to be adhered to for this protocol. So with that, Ansys has delivered a 5G wizard that takes the output of an HFSS analysis and allows you to do things like power density calculations, cumulative distribution function calculations, and all of this can be designed so that you can optimize not only the antenna itself, but also the antenna placement inside of a device. And then we can also further take that efficiency in that design and look at the biological effects. We can look at human body interactions. How does the electromagnetic energy that's radiated by these devices, how does that impact the head and the specific absorption rate? And we can use HFSS for the certification of these smartphones or user equipment devices for the different regulation agencies. Alongside of the antenna system design, we've got a lot more intentional radiation going on in a lot smaller package. So we know that there's going to be a lot of electromagnetic interference and electromagnetic compatibility problems. So we can take HFSS and we can use that to design and analyze our system to make sure that when we transmit on a particular channel, that energy is not then re-radiating back into the device for further problems with our memory buses or any other signal integrity issues that we might have. Looking at a little bit larger scale for antennas and handsets and IoT devices, one aspect of 5G systems is the fact that we have multiple inputs and we also have multiple users for a single base station antenna. So we have to have the ability to predict how that phased array system is going to couple to the individual user devices. And with Ansys HFSS, we can analyze that antenna array and make sure that it directs the energy in the appropriate direction for the individual user devices that are being under test. And we can even take that one step further and we can model entire city blocks and even larger with the Ansys HFSS SBR Plus solver. Here we're looking at a base station array in a fairly simple network environment in a city street. Here you can see multiple vehicles and that single base station array antenna is communicating with 5 different pieces of user equipment in different vehicles. And the antenna system has to adapt its antenna pattern to make sure that it is radiating in all those different directions. So this is another way that Ansys HFSS is helping design these 5G complex systems. And with that, I kind of want to wrap up with a summary of the overall solution for 5G equipment, whether it's network, infrastructure equipment, high data rate equipment, or even user equipment. Ansys has a multi-scale, multi-domain, and multi-physics capability that allows you to look at different devices within the system at the chip level, package system, for signal and power integrity of high bitrate systems. Also with our numerical products, we can look at optical integrity and do all of this for the different variety of equipment that may be encountered in the 5G system, whether it's network infrastructure or user equipment. And then we can also take that and combine that for RFI, EMI analysis, radiated susceptibility, as well as full communication link analysis in electrically large environments, and adding on top of that, looking at the full multi-physics of the problem, going from electrical, thermal, and then into mechanical domain. And that is why Ansys is the leader in simulation. We like to say from silicon to space. You can basically go everywhere from modeling down at the nanometer level for the silicon on optoelectronic drivers and receivers, up through the entire chip analysis from our semiconductor products, all the way through to package, board, system, and even larger environments, even modeling out to space with the capability from our new mission systems product group. So Ansys provides the golden sign-off for multi-physics solutions across all of these scales for power, thermal, electromagnetics, mechanical, and fluid domains. With that, I thank you for your attention. Hope you enjoy the show and have a good day.